the intermediate value theorem, let f be a polynomial function with real coefficient. If f of a and f of b have opposite signs, then there is at least one value of c between a and b for which f of c is equal to 0. So let's try here to prove it with a simple proof, this theorem. And let's say we have a specific function f of x is equal to x cubic minus 3x minus 2. This function is a polynomial function and is continuous everywhere. So is continuous in the domain from minus infinity to infinity. So now let's take one pen here and let's assume f of c is equal to 0. And for this specific function now, we can write the f of c is equal with, instead of the x, we are plugging in the c value. C cubic minus 3c minus 2. Let me write 3c minus 2. And now we see c is here somewhere, but if we are going on the left side closer to the 0, we see the f of x is negative, is down. And if we are going further from the 0, we see is a positive here, positive value. So let's go here with f of 1, which is closer to 0, and let's plug in, let's see, do we get a negative function here? And this is minus 1 cubic, minus 3 times 1, minus 2. As we see here, 1 cubic is 1, minus 3 times 1 is minus 3, minus 2, and we get a minus 4. So f of 1 is minus 4. So is this function in this side is a negative. So f of 1 is a negative. Let's see now the value of f. Let's say this is f of a. And now f of b, let's say we take in further than c here somewhere in this interval. And let's say we are taking 3. Let's hope this is a positive number. And this is a 3 cubic. Minus 3 times 3. Instead of x, I'm plugging 3. Minus 2. And let's see what we get. 3 cubic is 27. And here is 3 times 3 is minus 9. Minus 2 is minus 11. 27 minus 11 is a 16. So we have a 16 here. And now we see f of b, as we said, is a positive. F of a is negative. So the theorem says f of c should be between them. So it says in this interval between a and b, there is an element c that satisfies f of c is equal to 0. So now let's see here now f of 1, we already know f of 1 is a greater. F of 1 is is smaller than f of 0, because negative here is f of 0, and f of 0 is a positive number, is a 0. But 16, f of 3 is a 16, is a greater than 0, so f of 3 is a greater. And the claim here is a c is an element that is between 1 and 3. But if we are looking here, f of 2, if we take in f of 2, and we are plugging in here, in the equation, is going to be 2 cubic minus 3 times 2 minus 2. And already see 2 cubic is 8, minus 3 times 2 is 6, and minus 2 minus 8. 8 minus 8 is a 0. So it means a c is equal with 2. And 2 is between 1 and 3. So the element c is between 1 and 3. Or c is element of 1 and 3. So we all already completed this simple proof.